telling someone you're now going to need to wait longer for your pull request to merge. And the trade-off is that the quality of those merges are going to be higher and the company's going to have less downtime and outages. It's like wearing a seatbelt. Why would you not do that?
Hello, and welcome to Hangar DX. This is a podcast about developer experience and how engineering teams solve productivity challenges at scale. I'm your host, Ankit, co-founder of Aviator. At Aviator, we build AI code verification platform that creates guardrails and reduce AI slop. Today, we have with us Jonathan Block joining in, and we will be talking about scaling repositories. John, I'm excited to have you on board. Can you please do a quick introduction for the audience?
Yeah, you can call me Jon Block. 26 years engineering over here, mostly at startups. Most recently, I was at DoorDash for 9 years. Before that, I was at Lyft for a couple of years. I've been VP of Eng, of CTO a couple of times, and just spent a lot of time recently in my career doing things related to build and deploy. The founding member of the build and deploy team at DoorDash back in 2016. So I've got some insight, and I can tell some war stories. And I'm currently, by the way, the founder of LowRouchAdvisor.com. Where we can parachute in a senior or principal engineer into your Slack to give your team the guidance and direction that they might need. Most teams have the ability to write the code and do the things, but sometimes you lack, a specialist, especially when you're getting into something new like Bazel.
Cool. All right. I'm sure we will also put a link of this in our chat so folks can find you. So let's get started a little bit. So you've been also at DoorDash for a long time. You've worked in other organizations. How do large companies really manage repos, and what kind of challenges that come along with it?
Sure. I mean, so my commentary here is the collective experience of my career. This is not just like one job minus one or anything like that. But most places that I've been at, pretty much every place I've been at has used GitHub to manage their repos. And they've done what I call multiverse pattern, meaning that it's not a monorepo. So imagine you join, company X, like I've joined a lot of these. I was an early engineer, a lot of these places. Everybody's on GitHub and they're doing something small. Might be a PHP code base in one example, Python in a different example. And then things start growing and the engineers say, oh, we should probably do microservices. So they create more Git repos. And the code bases start to, separate into these different buckets. And over time, things start evolving separately in different pathways. People doing things one way over here, a different way over there. And as companies continue to grow, you got to figure out how are you going to be able to tell a consistent story, because if you're lucky enough to be part of one of these where you end up having a huge company, billions of dollars valuation, thousands of engineers, basically famous. How do you create order where there's eventually chaos? Because it's very easy to end up in a situation where there's thousands of repos. And imagine you're a build engineer and the company becomes a public company someday and someone says, hey, at your company, how do you guys, do SOX controls, compliance, and how do you do builds? How do you do deploys and that sort of thing? Well, what happens if there's thousands of repos? I love your product, Ankit. I'm going to give you a little plug here. It has the best, in my opinion, at least one of the best merge queues I've ever seen when I was looking for them. How do you go and deploy Ankit's merge queue to your company if you have hundreds or thousands of repos? It's insane. So when we're talking about scaling, I guess let me get back to the root of your question. So everybody starts minimally viable using, this is what I've seen, right? Like GitHub, then they start having more code bases, and then you start to get into some of the scaling problems that I've seen where you have a build team. Eventually there's a build team and they start to try to create order where there's chaos. And then you fast forward all the way to, where things are really big, like maybe Google sized. And you start getting into tools like I have on my shirt here, Bazel, which is one of the last things I was learning before I ended my run there at DoorDash. But
First, thanks for the plug on Aviator. This is not intentional, but obviously, there are a conversation between monorepo and multirepo, or an argument between that has been going on for a long time. For instance, I know that Google has historically been a monorepo organization. It has also helped them kind of standardize a lot of these toolings. At the same time, we've spoken with some folks at LinkedIn who are probably one of the largest multi-repo organizations. They have thousands of repositories. Um, So I think there are like pros and cons between those two. In your kind of like experience, do you have you seen kind of like one model work better than the other at scale?
This is in a way, it's like, snowboarding versus skiing. They can have people passionate about one or the other, even though they kind of both do something that's roughly similar. I mean, in my journey of becoming a build engineer, I saw a lot of Git repos and like managing them all in the different ways that they were done with different build tools was not sustainable. So, there's a lot of build engineers out there that are trying to scurry around and keep track of like how they can support all the different teams who are doing things in the multiverse pattern. A,
Right.
is a better way to have everything centralized, theoretically, yes, but maybe practically not. This is riddled with trade-offs, but my best guidance I could give to someone who might even be thinking about, the scaling problems and maybe even doing a monorepo would be, do not do this unless you have multiple languages and this is going to get much bigger. But if you are a smaller engineering organization, say you're a startup, some Y Combinator startup trying to do, like, don't waste your time with something like this. It would be total waste of time. The only gotcha is that once you're up and running and maybe you have hundreds of Git repos and, you have maybe build time performance issues and like that, getting into something like a Bazel or like Buck, like I'm not like out here trying to ram Bazel as a solution down anybody's throat, but it's hard to get into those, like restructure your software project to be um, Bazelified or maybe Buck2ified after the fact. Be much easier to like start something new in a project that already like has this activated. I want to call it that.
Interesting. So there are like different challenges alongside scaling repositories, right? Like one is obviously we have also experienced, I'm sure you have also have enough scars from this, which is Git itself is very hard to scale in the sense is, even Git fetches, Git pushes, all of those things become really slow at scale. But I think there's also, when we talk about things around merge queue, like, why this becomes important. There's also like, the whole deployment cycles, those become sort of like complicated. Can you share a little bit more about it? At what scale does merge queue kind of tools become useful? And how do organizations at large scale manage deployment, especially in large repositories?
Yeah. Okay. I'll tell you I'll tell you a story of, a few different companies I've been at, which I'm sure everyone can kind of identify with one of these three. When you're early and you have a Git repo, scaling Git or merging isn't even like someone wouldn't even really have a concept of like what a merge queue is because they might just commit to the main branch of development, what we used to call master. And then as you start, piling on more engineers, maybe you're using pull requests, you're using CI to some degree and you then have people merging their pull requests once they're green. And one thing that you might not realize is that when you see a green pull request, that doesn't mean that if you merge that the main branch that you merge to will also be green. So this is one of the biggest, misconceptions, I think, for anybody who looks at a GitHub pull request. You see green, CI, green, like how surprised must you be when you see, wait, the test passed, I merged, and now on the main branch, they don't pass anymore. Why? It's because your pull request is stale, because the main branch has moved along and has changes that you don't have, and that becomes a problem. And so, what I've seen is that, say like 3-4 years into a company's story, people are just doing that. They're like, I have a green pull request. It must mean that my code is good. Um, despite the fact that the pull request was open for 3 or 4 days. So they merge and then they move on. And then you have problems later on because as soon as they merge that, maybe the code actually doesn't mix. I call that the code mix,
Mhm.
right? So your mix that you branched off of from 3 days ago is fine, but you're stale. And if you were to bring those changes, rebase, people I call it a sync merge. But when you bring those changes in from the main branch, it doesn't work anymore, but you wouldn't know that. So anyway, that's where people start trying to solve that problem. But once you become like a serious company, you realize pretty quick you can't tolerate the production system being down from bugs as they enter in from any vector, right? So one of the ways that we can plug a source of bugs is by using a merge queue, right? So for those who don't already know, when your pull request is green and you use a product like Ankit's products, you say, rather than just merging on the spot, you submit your intent to merge. And a merge queue system will take the latest, greatest stuff from the tip of the branch you're trying to get to, which is usually the main branch or the master branch. And it'll put it on a throwaway branch and then combine that with your proposed changes and run CI again. And that's checking the exact code mix, which would be merged in advance. And that gives you like one last opportunity to validate everything's correct. So that's a thing that a lot of companies eventually decide that they have to do in order to keep the main branch defect free. I mean, there's other ways that bugs can leak in too, but that's a great we'll say pattern to use to avoid avoidable problems on the main branch. Like you just cannot tolerate that kind of stuff the bigger that you get. So people use that pattern. They don't love it. And I'll give you a little bit of an aside here, is that one thing I've noticed over my journey is that people like to do whatever they want. And when you become a bigger company, you have to do things through some pattern or system of organization. And you might not like that. And so when you're a dev prod engineer and your customers are potentially, let's say like 1,000 people, right? Even if you make 80% of those people happy with whatever you've done, 200 are going to complain and you're going to hear about it. So in a way, it feels like you can never win. But with whatever tools I ever worked on, it always did seem like it just felt like no one's going to like this and people aren't happy. Even when the thing that you're doing is in the best interest of the company and makes the software delivery system more reliable. So it's this Bazel's the same thing. This is like a hot button issue. It's like, because it's a whole different way of doing builds. Some people hate it, but it's a way to, do builds at scale. So I'm getting a little bit off right there, but yeah, on the topic of merge queue, essential pattern. And we can talk more. I mean, look, I don't mean to I think you've done a great job. So I'm going to take this a little bit deeper. GitHub famously has a merge queue. So someone might wonder, well, why did Aviator even make one of these things if it's something that GitHub already has? Let's talk about that. Because as your engineering organization grows, as have the ones that I've worked in, the GitHub merge queue is way too slow. It's like not even viable. Why? Because you have potentially thousands of contributors all trying to open pull requests and get their change in. So let's take a contrived scenario where 50 different people all tried to merge at the same time. What's going to happen? GitHub's going to try to, I mean, I don't actually know what we get the latest. We're in 2026 now when we're recording this, right? So maybe there's some new features there, but GitHub has a way of sequentially sort of going through one at a time. They might have a batching feature built in, but that's as good as it gets. But in reality, when you're part of something that's a bigger eng organization with a lot of people trying to merge at the same time, you need a high velocity way to get the work done. And so when the key phrase that I've heard talked about when we talked about our merge queue was this phrase swim lanes. And what that means is if I open a pull request and I'm touching a certain set of files over here, and you open a pull request and you're touching a different set of files over there, and our files do not overlap, in other words, they can't affect each other at all, that we would be able to merge our work at the same time instead of a sequential queue. That's essential. So that's maybe one of my insights, number one. Number two is this idea of batching. And I think between the two of us, Ankit, you're more of the authority. But to me, batching says, hey, let's all wait for a certain amount of time or for a certain amount of pull requests to queue up where developers have raised their hand and said, oh, please merge mine. Let's say we set the batch size to 4. Right? You imagine so now you have 5 people that are now waiting to have their pull request merge. Batching means at that point, we would combine their stuff together, run CI once against that code mix that includes everybody, and then merge that. That's a thing that some people might be okay with. In my worldview, that's not okay. And let me tell you why that is. Because, and I'd love to hear your comments on this, Ankit. When I look at the main branch of development, every one of those commits needs to be solid gold. Because there's this idea, like when you merge and when you deploy, these two concepts are very like almost married to each other. And so the concept of merging is also the concept of saying, not only am I merging the main branch, but this is now eligible to be released by some release process. And so, you have humans who are doing work, and then you have a deployment system, whatever yours is, that should be able to assume that every commit along the lineage of your main branch of development is built and is stable and healthy and deployable. And so, at least in my worldview, when we do batching, we're saying combine 5 things, validate the absolute last one, and we now know like that one is deployable and safe. But the other 4 that were before it might not even have been built or tested in isolation. And to me, that's too dangerous, because I want the deployment system or people to know that any of these checkpoints on the main branch are all safe. Well, those are just 2 insights from my experience. What say you about that?
I mean, these are like obviously a lot of these things are very close to my heart and something that we've been working together also for a long time. There's obviously like, at the end of the day, the way I think about it is it's a trade-off. You have to kind of like make certain amount of trade-offs in some places to get to the right amount of speed as well as accuracy. Right. So I think even in the batching case that you're describing, you can technically batch all of those things together, and that can provide you with some amount of speed. Now, the caveat here is obviously your builds need to be stable enough, because in batching, if your builds are not stable, it actually causes worse effects, because it compounds, especially as your batches start failing. Because once a batch fails, now you need to bisect to figure out which PR actually caused the failure. At the same time, batching can provide you with some amount of performance gains, where it's like, okay, now you're combining these changes together, so you've reduced the amount of CI load. Now you can actually merge them. With the caveat, yes, not in each individual change has been tested in isolation.
Yeah.
And those are kind of like the cases, you have to sometimes make a trade-off depending on how much scale and volume you're looking at. And I'm guessing like, some of the organizations, especially if you're using monorepos and thousands of developers working together, this becomes like also a challenge. I know like in case of Google also, they had like sort of like this pre-merge workflows. And I really like kind of like, some of the things that they did. Obviously, Google themselves were not built on Git, so they had like a little bit easier way managing it. But essentially, they combined the concepts of merge queue and Bazel as well, where it's like, you're kind of like actually always picking the latest targets, trying to merge it. And they internally also had like some sort of like slow builds running, where they will run build the whole corpus and sort of like roll back in cases when they actually see errors. But those error cases will be like 0.001% or even less than that. So that in most cases, you would never have to worry about those situations.
Mm.
So yeah, sometimes you kind of like just have to make some of those trade-offs to actually like achieve the speed or like the volume throughput that you're looking for.
Yeah. This topic of batching is closely, in my mind, related to a style of deployment that I've seen many times, that we call the train method of deployment. Maybe you've heard this as well. But for those who don't know, let's assume like you have a lot of people that are developing on your code base and they're merging. When do you deploy? Let's say you have a service, right? And it's Monday morning, 9 a.m. and there's 50 undeployed commits that have landed on the main branch. One of the styles that I've grappled with through my career was doing this train style, which means we would take the latest available and try to deploy that to the production system. And the production deployer would run, and let's say hypothetically, as it's deploying or maybe after it deploys, someone spots a bug. What happens there is you would revert back to the previous version, and so you would disappoint 50 people potentially in this example over one person's mistake. That is extremely painful. That's probably for a lot of people listening, at least small to medium-sized companies, that's what they're doing. And we did this for a long time because that's just a way to do it, right? Like especially when you have a long deploy, right? Let's say your deploy is 45 minutes. I had to deploy, I've dealt with hour and a half deploys where
Wow.
we deliberately would slowly release it. And you might be like an hour into a deploy with the automation, metrics monitoring, whatever, and you realize you have to stop it and roll back, and you're disappointing 50 people, and you're talking about hours of waiting for the rollback and the next one to go through. It's just like insane. So what would be a better way? I think this relates to our discussion here about batching. In my worldview, the better way is to figure out a way, using all of the tricks, to rapidly, build the deployable artifacts for each person's commit to the main branch of development, so that everything's always deployable. And you're using, when I say tricks, I mean things like build avoidance, right? So that we're always testing or building the absolute minimum, with tricks like incremental caching and that sort of thing. But when I think of major time that's been wasted, I've dealt with huge, PHP code bases and Python code bases and Kotlin with Gradle and all that kind of stuff. And I have to assume most of the industry is dealing with very long build times, where somebody goes and does something like a Gradle build, and then they take the results of that and they add it to a Docker image, and then they build this massive Docker image over a one-line change, potentially. Let's say someone changed like a README or like a config file, or like the forgot password page on some huge app, and it's like they have to run all the tests over. That's the worst case build scenario. And I think a lot of people just kind of have that because that's the simplest thing to kind of slop together when you're just getting started, something that just builds the whole universe. But like, you just cannot tolerate that kind of stuff. So as you get bigger, you need to find tools. Bazel's one of them, but there's other ways to do it too, that can figure out what is the minimum amount of effort needed in order to be able to build the next, releasable candidate, and run the minimal number of tests, and to generate that deployable thing. Yeah. So anyway, a lot of brain
Interesting.
power that was spent over the years, but a lot of time wasted also just doing trains and rebuilding the entire universe as part of
Mhm.
our build process.
If you're squint enough, you can kind of like see there is a lot of similarity between a merge queue and a build system, right? Kind of like some of the things that you're describing in terms of like the build avoidance, sort of like, using sort of like incremental caching, all of those things, you can kind of like also the same principles that apply in Bazel or like any build system also apply here in the merge queue. Let's switch gears a little bit. I do want to talk about like, unreliable builds, like flaky test, CI systems. Like, what are the impact of, flaky test within a merge queue or like within build systems? Like, how does that impact developers or like the productivity?
Well, of course. And I think one thing I think is true is that most developers think that it's a disaster at their company, but that other companies, they've like figured this problem out. And I think everybody can identify with the fact that some tests are just not reliable, and some are fixable and maybe some aren't, because they're like integration tests and they're just dealing with like external stuff in a way. So how do you solve that? There's a bunch of vendors who have tried to solve it with onboard tools. Maybe you guys have. I think you actually have a product. So like, if you're using a vendor or solution that has that, turn all those features on. Some build systems allow you to like automatically retry up to X number of times, and if you can at least get one pass, that's fine. When you use a build system that has build avoidance built in, it won't even run your test again if the code that is tested hasn't changed. So that's a major win, right? Like, you won't even stumble into a test that itself is flaky in the first place. Then there's a question of like, what do I think could be a good way to deal with this? And maybe some of the vendors have done this. In my mind, the right pattern for dealing with a test is a kill switch that disables the test for everybody who's affected. Because if we were to think of, let me come up with a contrived example. Let's say, for example, someone added a test that fails on a certain day of the month, when the number of when the last day of the month is like, it's a leap year, one of those kind of like a date-based test where someone didn't properly mock the clock. So eventually it gets to be that day where you might have hundreds of people who are all disrupted now because there's one bad test. What are you going to do? You're going to go in and like someone fix it and then try to have 100 people all rebase to pull that change in? That's crazy. So I think the best pattern would be a solution where you can go in and target the broken test and flick a kill switch that affects all of the CI or the open branches. So you would need a product that sort of does that. It's able to sort of like register what tests, and then when it runs the test, it would actually be sensitive to the kill switches that are currently active, in order to avoid that sort of thing. in my worldview, that's the way to do it. And as far as like knowing how do I even define what a flaky test is? Um, in my mind, the answer is a test that passes on the main branch, which obviously all tests are supposed to pass on main, but that doesn't pass on multiple feature branches. That's like the way that I've personally, like, set call it a sensor. I'm sensitive to that particular thing because if someone opens a branch and they accidentally break some code, that might fail a test. But if across two different pull requests, maybe by two different authors, if someone sees the exact same problem but it's passes on main, in my mind, that's definitionally the flaky test that you would want to be able to kill with some sort of a kill switch. But
Mhm.
yeah, I mean, flaky tests are obviously extremely disruptive, and I've when I'm writing code, I've gone to great lengths to try to make my tests like pass in a millisecond and not take any external hard dependencies and like that. But maybe not always possible, especially like I said, like when you're doing like sandbox testing against some external environment.
Have you kind of like used any kind of like policy to this to help reduce flaky tests? Because in some ways, everyone hates flaky tests. And I've seen also like, some of the examples that you have given, people will mark certain things as flaky. Maybe it's sort of like some things where builds don't automatically fail, or maybe there are like some retries. But effectively, we want flaky tests to be gone, or like we want flaky tests to be fixed. Is there like kind of like even a cultural practice that you can follow to at least like reduce the flakiness in the system? Or it's like, maybe you can just ask every like if a test fails after X number of times, you just like disable that test or delete that test, or maybe like,
Well, the
force the developer to
closest
go and fix it.
closest yeah, closest pattern I've seen to that is that when you have a lot of software teams, people own certain parts of the code base or they own certain microservices, and that when a test is seen as flaky, the best policy I've seen is that it becomes the responsibility of the owning team's on-call engineer to deal with it. You don't wanna have a culture of people that just keep rerunning the CI over and over again to get it pass. It has to be turned into like an actionable Jira or maybe a PagerDuty or whatever it is. But the thing that I've seen at big tech, the places I've been at, is that each team has a Slack channel where their on-call engineers hanging out, and they can be summoned by anyone just kind of dropping in and like reporting a problem, or you can have automation if you have flaky test detection. You could have something like try to route to whoever the code owner is for the test that's broken and assign it to that person as their like first, you know, well, I guess keeping the production system live is of responsibility number one, but like fixing the test and unblocking other people in the terms of their productivity would be like priority number two, I think, for the on call.
Speaking of like cultural things, maybe kind of like changing gears a little bit, I would want to understand, this is also like useful for me in some ways, right? How do you actually convince engineering organizations to adopt merge queue? I think it's like almost like two folds. One is you need to convince maybe the leadership or sort of like the platform organization or like of the team to adopt it. And the second is sort of even showing the value of that to the developers, right? So it's sort of like maybe one is looking up versus one is looking down in some ways to uh, get better adoption and success with merge queue. What have you seen sort of like as success and failures in terms of like adopting a merge queue culturally?
Okay, well, look, I will tell you that this is just not like nobody wants to have to wait. And what you're doing here is you're telling someone you're now going to need to wait longer for your pull request to merge. And the trade-off is that the quality of those merges are going to be higher and the company's going to have less downtime and outages and so on and so forth. So in terms of like convincing someone, it's just the bottom line is that you're going to leak more bugs onto the main branch if you do not do this. It's like wearing a seatbelt. Why would you not do that? It's the only responsible thing to do. So if you have like a small project, if I'm just doing a hackathon or throwing together something for fun, of course I would not use a merge queue, complete waste of time. But when you're talking about like shipping something that's business critical, or especially if you automatically deploy, because the more sophisticated your end gets, the more likely that a merge actually triggers the deployer. And there's patterns out there where like once you merge, your stuff could be live in within seconds, depending on like what kind of a system you're working on. And so that code better work, or else you're going to be disappointing a lot of people. And so you can't like afford not to do it. In terms of like convincing, I mean, I think that's just the bottom line. It's the only responsible thing to do in my mind if you're working on something that matters. But if someone doesn't like that, maybe they just they should work somewhere else or at a smaller kind of a shop. But you have to, in my mind, it's just an irresponsible thing to not.
Interesting. I've also heard like some folks, talk about potentially a capability which is like post-merge reverts, which is like, okay, let the changes merge. If it breaks the build, then you revert it back. Like, what do you think? Is that like a possible viable solution? Does it work at
No,
scale,
I
or
think
like
it's a
maybe does
terrible
it
idea.
work?
Terrible idea. You're going to waste everybody's time. Let's go back to another example. Let's say I merge, we're going to use merge revert. As soon as I merge my broken change in your example, I'm going to have other engineers that are creating new pull requests off of that broken change. So they're going to waste their time dealing with the problem I introduced. Like, that's not okay. And the more people that I'm disrupting with my bad change is like, that makes the problem. They're going to be so mad. It's just like people want to not waste their time. Like, that's one of the key fundamental things that like humans are concerned with. Do not waste my time. So on one hand, someone will be like, I don't want to waste my time waiting for the merge queue. I get it. Nobody wants that. But what's worse is wasting 50 other people's time if they've created branches because they're trying to get their work done too. So you've multiplied the problem many times over by disrupting all the other people who assume that the main branch was healthy. So I think that's the way to think about it, is like the main branch must be healthy and it must be automated in terms of the health checking, right? Through things like the merge QCI runs and so on and so forth. It's funny, like I remember in my earlier days or in the earlier stages of companies, a lot of the validation of things would happen after we would deploy because we didn't have a lot. And I'm not saying this is a company or another company, but this is often a thing. You don't even have the facility or the automation to go and like check all the things, maybe through staging environments and canaries and like that. You have like an open PR, you test it in some sort of like your own personal sandbox. You deploy, and then you really hurry and you go and you test something as quickly as possible. The bigger you get, that's just not even like possible anymore. So the bigger you get, the more essential it is that when you see a green dot, it is safe to deploy. Like, you have to be able to count on that. And if someone were to put out a bad change but there was a green dot, it's not like shame on them for not checking something. It's like now the responsibility of the automation, people, engineers, or to get back into the pre-deploy or maybe the pre-merge steps and figure out how to exercise that case again. It's the only way that would scale. Especially when you're dealing with like
Interesting.
hundreds of people, right? Thousands of people. It's like everyone, like you might go and have to make a small change to something you don't know, like the programming language maybe. You CD into some folder, you see a little fix you need to make, and if you see in green, you have to be able to have confidence that like it's gonna merge and it's gonna deploy okay.
Right. I think that's actually
Yeah.
like something which is very important, especially at a large scale, is having that reliability. Right. And I think in some ways, like a scale comes a layer of responsibility that a developer has to understand. Okay, so kind of like maybe we are coming close to the end. So perhaps one question, which is, given that we are in 2026, we have to talk about AI. So
Yeah.
one, I feel like there are two both advantages and opportunities as well as challenges when it comes to AI. One is that, the amount of changes that are getting merged is just like increasing rapidly. Right? Obviously, people are using AI to kind of like create a lot of code changes as well. But there is maybe potentials of using AI to improve some of your build systems. Do you have any thoughts on that?
Yeah, two things come to mind. Number one, I think the amount of code that's being automatically AI generated and deployed into live environments is very terrifying because it's very low quality. And I think that there is a big opportunity for AI generated code to be checked and more deeply. But I think you have a lot of people that go to these things and say, "Oh, great! I just typed a request to have something be built." And then they put it out there without any awareness of things like related to security or compliance or and that sort of thing. So anyway, I'm a little bit worried about the amount of people that are like, this is great, now I can start putting things out in front of customers. And I think that there might be like another wave of um, security compromises as a result of all this AI driven stuff where like the person who created the code through AI didn't really understand the consequences of the code that was generated. That's my first thought with respect to AI. The second thing is that as an engineer who knows what you're doing, right? Not just a prompt typer, but someone who actually knows what they're doing. Um, build systems like a Bazel or Buck2 or Gradle or whatever it is, they're kind of hard. And the developer wants to spend the least amount of cognitive load doing other stuff that's not pure business logic. I want to be able to go in my programming language, open a source code file, and implement the next feature. And I don't want to have to learn like 100 other things. And it's very easy to end up having to learn Terraform over here, or details about Kubernetes, or Bazel build system and like that. There's too much of that. So I think where the next wave of opportunity lies with respect to build would be in systems that are able to capture what the team's intent is, and the
Hmm.
implementation skills around how Bazel works, or Bazel build files and rules and all that kind of stuff that developers need to kind of touch, if assuming you're using Bazel as my example. That just really wouldn't be that much of a concern, and it could be somehow pushed down to a lower level. Now you have to balance that against what I just said in my first point, right? Like, it's going to do the right thing. But I think that there's probably opportunity there to sort of just like get it out of the way, and create a space where like the developer can just focus on the features that they want, and the build and the deploy and all that other stuff is provided in a way that you don't need to understand it. So hopefully there's a
Yeah.
pathway there that AI unlocks.
Yeah. No, that's really interesting, right? In some ways, we also talk a lot about intent-driven development, which is like focusing on mostly what you need to do, and you can abstract away a lot of complexities, especially with AI. Like, even think about systems like Terraform, which can be really hard for organizations and people to learn, which can actually now be abstracted in some way, or like even be AI generated and verified in a different way before they get deployed. All right.
Right.
So I know this is like, we barely touch the surface on merge queues and like managing repositories and managing builds. I know we can talk on this forever, but Jon, we are at time. So thank you so much for joining us here. This was a blast. Learned so much about merge queues and Bazel. And thank you all for listening, folks. If you're interested in developer experience or work in DevOps, please join us also in HangerDX community. We run virtual sessions and podcasts. Um, and again, thank you again, Jon, for joining us. Hope you have a great day.
All right.